everybody, this is our lesson on the electromagnetic spectrum and visible light. So by the end of this lesson, you should be able to compare waves based on their characteristics. So we're looking at our last type of wave here. So let's talk about electromagnetic waves. We did mention these in the first lesson, so I just want to do some review. So these are transverse waves produced by the motion of electrically charged particles. These do not have to have a medium to travel through. So these are the ones that you do not have to worry about what medium it is, temperature, things like that to make them travel. These are often referred to as electromagnetic radiation. And just for review, radiation is the transfer of energy in the form of waves. Does not need a medium to travel through. It travels at the speed of light, which is 300 million meters per second. These will slow down as they pass through matter. So this is the one time that, normally sound waves, especially travel quicker through matter than they do, like through solids than they do through gases. Here, these slow down. And remember that a shorter wavelength equals a higher frequency, so that is an inverse relationship. As one goes up, the other goes down. So we have what's called the EM spectrum, and this is an arrangement of different electromagnetic waves in order of wavelength and frequency. So we tend to start off with large wavelengths, very low frequency, and we work our way up from there. And remember that the amount of energy that's carried by the wave increases that frequency. So these first couple will be lower energy. The only portion of this spectrum that is detectable by humans is the visible light portion, which we'll go over. And just in case you see this for reference, when we talk about light, we usually refer to these as photons. So now let's get into the types of the EM spectrum, and you have probably heard these before, so a good bit of this should be review. Our first type is radio waves. These have the longest wavelength and the lowest frequencies, which means they are the easiest to interfere with or interrupt. Think about as you're driving from here to the beach, you have to end up changing radio stations as you're driving, and that's because you're getting too far away from towers that there's so much interference it can't get to you like it can when you're closer to the source. So radio waves are used for radio, cell phones, medicine, astronomy, television, all those different things will use radio waves to process that information. And we also have what's called modulation, and this is the process of varying radio waves so that, they reach different areas and different sources at a time. And we can look at this with AM and FM radio if you've paid attention to that. AM stands for amplitude modified and FM stands for frequency modified. Our next type is microwaves, and these are a form of radio waves with the highest frequency and energy. So as we've increase that frequency, we're moving into stronger radiation, which is microwaves. These are used for weather forecasting, microwave ovens, and certain types of communications. We also can use these for radar, which are short wavelength microwaves that you can use to locate objects or monitor their speed. So, like the radar guns that police officers have when they catch you speeding, that's using microwaves. Our next type is infrared. So we're moving up. So we're increasing frequency, which means we're shortening our wavelength. So these are becoming stronger waves or stronger types of radiation as we are going, which should make sense because radio waves, we're exposed to them all the time. They don't really do anything to us. Sometimes long-term exposure might hurt us, but it would take a lot. But now we're getting into, microwaves. You shouldn't be standing near a microwave and watching it. They say that leads to mutated cells, infrared. We're going to get to stronger as we go. So infrared has wavelengths that are just slightly longer than visible light. And these are also known as infrared rays. And these cannot be seen, but they can be felt as heat. And you can actually use these for thermograms, which are photographs using heat, or like night vision goggles, which I talk about here. You can use this for looking for heat. Okay. So infrared sensitive binoculars and cameras can be used for night vision, and they can be used to warm or dry objects. One good example, I shouldn't say good, I mean, it was a horrible incident, but infrared scanners were actually used to find the Boston Marathon bomber when he was hiding in a building at some person's house that he broke into the building. He was hiding in their boat. And as they were scanning with infrared technology, they were able to see him as a heat source, and they were able to find him. So that's one way to use infrared technology. Our next one is visible light. So this one is not harmful to us, but this is the only one that we can perceive and actually see. And we see our colors of the rainbow. So Roy G. Biv here, you should know what those colors are. And this is produced by very hot objects. So when we see color, it is electromagnetic radiation off of heated objects. And this can stimulate certain chemical reactions like photosynthesis in plants. Our next form is UV radiation. We should know that this one can cause damage to us as exposure is increased. This is what causes us to get sunburned. So these have frequencies slightly higher than visible light. These are responsible for sunburns and skin cancer. So you just have to be cautious with those. And then our next form are X-rays. So these are shorter wavelength and higher frequency than UV. And these are used for X-rays of bones, insides of objects. You see these when you go to the airport and they scan your stuff, your carry-ons. As you can tell, SpongeBob is giving Patrick an X-ray here. And that's also, if you have ever gotten an X-ray, they lay that lead blanket on you. And that's because X-rays can damage tissue of soft tissues in the body, organs, certain systems. They don't do damage to harder calcified parts of the body like your bones. And then our last type here is gamma radiation. This is our highest frequency and shortest wavelength, which means it is the most intense or strong type of radiation on the EM spectrum. It is the most penetrating. If you remember from when we looked over radioactive decay, it takes concrete or lead to stop gamma radiation. And I mean a lot of lead. This is emitted by radioactive particles, and it can be used to kill cancer cells, but it's also very limiting because it does damage healthy cells. As science has progressed to make cancer treatment much more pinpointed to the actual damaged cells, we still, have the casualties of close healthy cells as well.